Hi guys, welcome back to another episode of Laid Off. This is Mike, and today we'll be talking about a new problem from LeetCode. And that problem is pretty famous. I think everybody heard about it by now. It's all over YouTube. Every single quote-unquote content creator made a video about it. So, it's a pretty well understood problem. So, there's not much to add at this point, but I'm doing this for myself and sharing it with others. I think I could provide some intuition behind the solution, and I'm practicing until I get some offer. So let's get started. I'm talking about the two-sum problem. Okay, it's actually problem number one called the two-sum. And there is another version of it called the three-sum, but I wouldn't talk about it now. It's a little bit extra, a little bit different, I would say. But yeah, let's see. What is a problem statement? What are we trying to do? What we're trying to do is, if I give you a list of numbers, let's say 3, 0, 5, 1, I don't know, maybe let's say 9, okay? And I give you some number, let's call it target. And I don't know, let me throw some number, let's say 9. And then I ask you, find the indices of the two numbers that adds up to 9. Okay? So, for example, if you look at that list, I need two numbers to add up to 9, and in that case, I can see I have 0 plus 9. That gives me 9, so that checks out. So in that case, what is the answer? The answer will be index 1 and index 2, 3, 4, index 4. Why is that? Because we are supposed to return the indices, not the numbers themselves. Okay, so the indices, let me highlight them: index 0, index 1, index 2, index 3, index 4. Okay, so that's why it's index 1 and index 4. Is that clear so far? Okay, so now the challenge is we need to find an efficient solution. How can we do this efficiently? It's very easy to do it by eyes, but computers don't have eyes. So if you're an idiot and you're trying to find the solution, well, what you could do, you could be trying every single pair. What do I mean by that? You could try, oh, well, I'll try 3 with 0. If it doesn't work, I'll try 3 with 5. That doesn't work, I'll try 3 with 1. Doesn't work, I'll try 3 with 9. Okay. And then if none of these work, you will try even more. You will try the 0 with 5. You will try the 0 with 1. You will try the 0 with 9. And then, here you're going to find a solution, but you could be unlucky and you still cannot find a solution until the end. So what's the problem with that particular solution? Well, you're trying every single pair, every single unique pair. And how many trials are we doing in this solution? Well, how many arrows? Let's count the number of arrows here. So the 3 will be tested with 0, 5, 1, 9. How many comparisons we're doing? We're doing 4 different comparisons. 3 with 0, 3 with 5, 3 with 1, 3 with 9. Okay, and then after that, we're doing 0 is 5, 0 is 1, 0 is 9, so 3 more comparisons. And then we're comparing the 5. If none of these worked, I'm gonna try to do the 5 was 1 and the 5 was 9. So 5 was 1, and then the 5 was 9. It's 2 more comparisons. And then the last comparison left, which is the 1 was a 9. So how many trials this will add up to? Well, these are 10 different trials. That might not sound a lot, but what if you have a list? Let me repeat. So these are 10 different trials for a size n equal to 5, okay? You have 5 different elements in the array. Now, okay, what if you have, what if the array or the list is, let's imagine you have 100 items. How many comparisons do you think you will need if you use this solution, which is, will never get you any job? But what do you think? Well, if you have different 100 elements, like imagine you have a huge list. Well, the problem will be is you're trying, how many comparisons would you have first? Well, let's see. You have the first element, second element, blah, 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 until the last element, okay? So you have index 0 until index 99. And so what you're gonna do, you're gonna do the same thing we did earlier. You will try index 0 with, how many attempts will you do? Will you do index 0 with index 1, index 2, index 3, blah, 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 blah. How many are you gonna do? You're gonna do almost 99 trials, okay? Okay, and then after that, you will do 98 trials, and then 97 trials, and then 96 trials, all the way until you end up with 1 trial. That's the worst case scenario. I'm talking about the very worst case scenario. So if you, I'm not sure if you did middle school or high school or something like that, this is summation has a name called our arithmetic sequence, right? And it has a formula. And when you add all these numbers up, you will get actually 99 multiplied by 100 divided by 2. So in general, if you have 1 plus 2 plus 3 plus yada 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 until n, this will sum to n multiplied by n plus 1 divided by 2. So, and then if you do this, you give you n squared plus n divided by 2, which you could simplify, and you get 1/2 times n squared plus 1/2 n. Okay, so what does that mean for us? Well, it just means that that solution is all of n squared. And that's bad, okay? That's pretty bad. You won't get any jobs, and they might kick you out of the interview. Okay, so what can we do now? What can we do? So there's a different solution we can try. And what is that solution gonna be? What we can do is, so what we can do is take advantage of sorting. Okay, why is that? Okay, what happens if the array is sorted? So if you have a sorted array, and now let's be a little bit more abstract. A, B, C, D, E, F. And I'm telling you that this array is sorted. So you have A less than or equal to B, less than or equal to C, less than or equal to D, less than or equal to E, less than or equal to F. Okay? And I'm trying to reach some target. Let's call a target equal to T. Okay? Some target T. Now, what can we do? Well, if I start by the far left and the far right, A plus F, there are 2 different cases, okay? So if I try A plus F, there are 2 different cases. Either that will be larger than T, larger than the target. Could be less than T, or could be equal to T directly, and that will be perfect. Okay, so what if it didn't work? Let's see. What if none of these worked? I mean, one of them has to work, right? So that doesn't make sense. So if it's larger than t, what can we conclude? If a plus f gives me a number larger than t, what can I do is, can I do a plus e? Or which way can I do if I tried a plus f? This guy plus this guy. Well, if that gives you larger than t, can I do a plus e? Or can I do b plus f? Which one makes more sense? Well, if a plus f bigger than t, that means b plus f is also bigger than t. One second. If, then. Okay? Why is that? Well, these are the same number. This is the same. But I know that b bigger or equal to a, which means b plus f has to be bigger than a plus f, which also means c plus f is bigger than t, and d plus f is bigger than t, and so on. So if a plus f bigger than t, then I should not try anything with f after a. Anything after a, I should not try it with f anymore, okay? Because of this. So that will save me lots of computations, okay? Okay, now let's look at the other scenario. What if, so we covered that case. If a plus f bigger than t, then this is a conclusion over there. Okay, so what if it's less than f? What can we do? Well, if, let me do another one. If a plus f less than t, that means that a plus e is also less than t. And a plus, what was the other letter? D less than t. Okay, which means I should not try anything else after that with a. Why is that? Because any summation I do will always give me a result less than t. So let me put then. There is no point of doing all of these. This is not needed. And same here, this is not needed. Okay? Okay, so that's the conclusion. I'm saving myself lots of computations that are not necessary. All of this by simply checking that condition. That's it. Okay, so this is basically the intuition of this solution, which is we will start by the far ends, okay? Far left and far right. And then we check. Does it give me the sum bigger than t, less than t, equal to t? If it's bigger than t, then this guy needs to move to the left. Why? Well, we discussed that over here. Now, if it's less than t, if a plus f less than t, then it will be the left guy has to move to the right. Now, why is that? Well, we mentioned that down here, because all of these are not needed. Okay, so in general, if the summation is less than t, what you do, you get move right. If it's larger than t, well, you're trying to make it less big. You can do move left. And then if it's equal to t, you're done. All right? So this is the intuition, and this is probably like the theoretical background. And then the next section, we will be writing the code. But that's basically the idea, okay?